Hello and welcome to the fourth video in the series making simple Flappy Robin for Android using Cocos2dx version 3. So this video then, one of the most important parts of the whole application, that is dealing with the scaling. So first thing I want to do is I want to add a new file. I'm going to add a header file to the project and I'm going to call this constants.h. And the main thing with this file is, irrespective of which IDE you have, is that inside your project folder, inside the classes section here, you have your constants.h. And what we're going to do, without further ado, inside the constants.h then is just start defining the stuff we're going to use. And so far we have k, z index, and I'll call it bg for background. I'm just going to say 0. Now I'm going to define k, z index floor, which is obviously the z-index for the floor that we've added, and I'm going to put that as 40. That's because we're going to be adding some things later on that are behind the floor, but obviously in front of the background. And what that means inside hello-world.cpp is that at the top we want to just include and then header and the constants.h, and then obviously in the initialization I want to have the k z-index background for the background, and then the k z-index floor for the floor, like so. So we're neatening things up a bit there. Right then, onto the scaling. To do the scaling, we're going to add a new class. Now when you add a new class, you need to make sure, that's important for Android compilation, that you also add something to a file inside the Android project part here. If you go into the project.android into JNI, you have an Android and application.mk. Inside the android.mk, which I've just got open here, it looks something like this. You need to make sure that you add your classes, that you're adding the CPP files like this, so they then get compiled. And I think you actually have to add them in alphabetical order. Make sure everything's in alphabetical order as well, but I can't exactly remember, to be honest. But make sure you add them in like this. So if you wanted to, we're going to add something called C Game Manager, then, oops, I'll just do a Z there. Then I would want to be copying and pasting in this way. What am I doing here? Going mad. Like so, and just call this C Game Manager, and I'll just copy this name as well, like so, so that actually when you're doing it under Eclipse compiles then for the Android version. That's very important, otherwise it won't compile. So let's do that then. Let's just right click on classes and new file, and we're adding a C++ class. The targets are checked, and I'm calling this C Game Manager and clicking create, and we're good to go. So this C Game Manager is basically going to be what's called, well, basically it is going to be what's called a singleton class, and that means that if you use Java a lot, you'll be familiar with this quite a lot already, but it basically means that we're going to have one instance of this class, and this class is accessible throughout the application. And the way you do this is by having a static member variable of the class which you reference all of the time. It's created on application startup, and then you always reference it. And what our game manager is going to do is it's going to manage the changing of scenes. When we go, say, to the settings scene, it's going to manage the saving of a high score, the saving of our volume settings for effects and the music, and it's also going to handle the getting of the correct file name for a sprite, and also the correct scale factors as well. So to start writing it out then, we'll call it class, and I've already got copied the name, C Game Manager. And the first thing we want to do is set up some of the public parts of this class then. So the first thing is we have our static C Game Manager, which is our instance. So this is a function that we're going to call instance, returning a pointer to one instance of this manager class. And what we'll have inside the implementation file, so the CPP file for this class then, is this static C Game Manager, but is accessed using this instance. That means you've already seen, for example, with the Hello World scene, something similar here where we've got director get instance. Well, that's this one available director. Well, we'll be doing C Game Manager and an instance to get our one instance of the game manager. So we're always using the same one. Sorry if you can hear some banging, by the way. What we then want is a function then belonging to this class, which we'll call lateInit, is for late initialization. And then we want a get scale x, which gets the scaling that we have in the x direction. We want to get scale y, which will get the scaling in the y direction, and also something which may be a bit confusing called get scale factor. So the way we're going to deal with the scaling I'll explain now before we go on. We have three sets of graphics, remember, based on 480 by 320, 960 by 640, and 1920 by 1280. And we will decide in application startup which graphics set we're going to use, and that will give us our scale factor. So it'll be a 1 if we're using the 960 by 640 graphics, a half if we're using the smaller, and if we're using UHD, then it'll be a scale factor of 2. But say we're using the scale factor of, say, a half, but the resolution isn't 480 by 320, it's actually, I don't know, 440 by 300. We need then to scale everything in an X and a Y direction to make sure the graphics still fit properly on the screen. So that means we need this X scale and Y scale as well as our scale factor, which decides then so these are then to scale, these two here then to scale the image that we've got in our correct resolution onto our screen. The scale factor then is used, for instance, if I say I'm using a font size 24 on our 960 by 640 screen, but then we've got the UHD resolution, then I would want to multiply this by the scale factor to actually use a font of 48. That's just a slightly bad example because I think the fonts already automatically scale, but you get the idea anyway. Some things will need to scale twice, such as speeds, for example, so pixels per second or something, depending on the density of the screen. So we'll need this scale factor as well. And don't worry about it too much if it's a bit confusing. You get to realize how it's used during the programming application. So what we want now is we want set up scale factors, which is what will be called when the application starts up, or when we first start our scene, actually, our main scene, which will be the Hello World scene at the moment. And then one more is a get file name. And the reason we've got this here is inside helloworldscene.cpp I've typed this in, but of course we don't know what extension we're going to need using. Our game manager knows what extension we'll be using. So what we'll actually do is we'll have an array defined in here of characters, say up to 32 characters. We'll send in this array, we'll send in the character string BG, and then we'll ask Game Manager to append the full file name into that array, and we'll then use that array as the file name here. Sounds a bit complicated, but it isn't. That's just we'll use the Game Manager to get our file name for us. So we take in our array that we want, and then the length, and then of the array, and then the const char, and the name of the actual file, and then the const char, and the file extension as well, in case we're not going to be using PNG. So this file will be used then to fill this array with the correct file name. You'll see how that will be used again in the code, so don't worry about it too much. So now on the private side of things, we need to do this setup of the singleton with our constructor, and then the copy constructor, and also the equals operator. This is fairly standard stuff. If you type anywhere looking at how you do a singleton pattern in C++, you'll see this. And then last but not least, oops. Why have I gone onto a hat? Because the keyboard type has just changed. Sorry about that. Okay then, so that then sets up the copy constructor, the constructor for, and the equals operator for our singleton pattern. And now what we have is our static member variable, which is private of our C game manager, and that's the actual instance of our class. So this is the instance that will be returned by this instance here. And if this instance happens to be null when this is called, then it'll be instantiated and returned. So this is every time we reference our C game manager instance, this is the object that's being referenced. And then we want some further private member variables. So we want a float scale X and a float scale Y. And then we want the scale factor, And the last but not least, we want to maintain, which will set up the extension that we'll be using, either -hd, -nd or -uhd. So that then's the setup or the basic structure of the class itself. We'll come back to this file in a minute, but for now let's set up the implementation file of all this before we go any further, otherwise things are going to get a little bit confusing. I'm just checking something here. Yes, we need to copy this, include Cocos2d.h, and now we'll go into the implementation and just drop that inside here. And I also want the using namespace Cocos2d. I thought, yep, that's here, just inside hello world scene.cpp. I'll drop that also inside here and save. And I'm a bit worried because that's not gone blue and the IntelliSense hasn't picked it up, but never mind. Okay, so the first thing we want to do is define as constants our extensions. So I'm going to say kxt hd, which is obviously then just the -hd. And let's just copy and paste these twice. So we have our UHD and our ND. So extension ND and extension UHD like so, which sets up our constants. And now we can start dealing with the class itself. So we have our CGameManager and then our CGameManager pointer. It's a pointer, isn't it? So we've got a pointer to our instance, so p and instance, and that's set equal then to null, sorry, capitals null, like so. I'm just going to hit build on here because the indexing seems to have broken on the IntelliSense. And why has it got a problem with this? Because I've got the double colon in the wrong place, sorry. Okay, and just hit build again. Okay, good, everything seems to be okay. So that's our instance then that'll be created when we call the instance method. So if I just go then to CGameManager, and now we're returning a pointer to a CGameManager, and that's our instance function. Right, I'm just going to, you won't notice a pause, I'm actually just going to close and reopen Xcode here because the IntelliSense seems to have completely broken. It's going to make everything take longer. Okay, I'm back. Hopefully I've cut all that out for you, but the indexing you can see with the colours now is actually working because that was bothering me. So what we want to say then is then inside this get the instance, if we haven't got our p instance, so i.e. it hasn't been initialized yet, then we can say p instance equals new and CGameManager, and that's all we need to do there, and then we return simply from the function our instance. So hopefully you can see now how it works. We call this function every time we want to access the game manager, which gives us then this one object here that we'll be using throughout the program. So now we can set up some of the easier functions then. So we have our float and CGameManager, and it's get scale x, and here then we just return our scale x. And I'm just going to copy this down a couple of times, try and speed things up, because this video unfortunately is going to be a little bit longer, as you can imagine already, than most of them are. And then here we want the get scale factor, and inside here we want to return obviously our scale factor. So that's those set up then. And now we come into one of the more important parts, or the most important function probably, and that's the setting up of the scale factors. So we want here a float. Oh, is it a float? No, it's a void, isn't it? So a void CGameManager, and then set up scale factors. And the first thing we need to do is get our visible size from a director, which we already have a line that does this inside hello world scene.cpp. So I'll just copy that and drop that inside here. And now we'll set the extension property already equal to our standard extension, which will be using the HD. So we'll just say here the CARM pointer to kxt and then the HD, because remember our base resolution is our 960 by 640, so we can already set this extension up. And we can also therefore set our scale factor, because we'll assume that's what we're using at the moment, or scale factor as I've got there, as 1.0. So now what we can do is say, do we need to use either the smaller or the larger graphics? So we can say that if our visible size dot width multiplied by our visible size dot height is greater than 960 by 640, our base resolution. That means we'll want to use our UHD graphics. So we say our scale factor is equal to 2.0 because we're going up by a factor of 2 because we're using the ultra high definition, and our extension now then will be equal to a car pointer of the K ext UHD. So we can say else if, and then I'm going to be very lazy here and just copy and paste this in and then change the values. The width times the height then is less than or equal to, remember, because we want to be less than or equal to for the smaller one, 480 by 320. Then we want the scale factor now to be 0.5, and we want to be using exd nd like so, because we're now going down by half and using the extension with the smaller graphics, the dash nd. So that sets that up then. Next thing we need is our scale factors, or sorry, our scalars. So for our scale x, we have then the visible size dot width divided by then, and it'll be 960 multiplied by our scale factor, like so. That should be fairly self-explanatory. And then our scaling in the y, is the visible height, visible size dot height with 640 multiplied by the scale factor. So that's all we need to do then actually to set up our scale factors and everything like that. And the last bit of the class that we need to implement is this getting of the file name. So we have the void cgame manager, and now we've got the get file name with these arguments. I'm just going to get the definition from here to speed things up a little bit. Like so. And what we first of all want to do is take our array to memset our array. So we just say array and then 0, and then the size is size of, and then car multiplied by the length of the array that's being sent in. So we set our array to 0, and I've done array rather than array. And now we can just use sprintf. There are other ways obviously with C++ of doing this, but I really for this stuff prefer to use the old C way of doing things. So here we want our %s and %s for the name extension and the file extension. So what we want here then is the name sent in. We then want the relevant extension, which we've set obviously here in the function above. That'll be the -hd or whatever. And finally then we want the file extension .png whatever to go on the end. And that's all we need to do then, so we can just call this function whenever we need to get an actual file name properly for our graphics. So all that's saved and done now. There's one more painful thing, however, we do need to do, and we're going to add inside the game manager here some macros. So I'm going to make lots of space here, and we're going to add some macros in just so that we don't have to type that we're getting this C game manager instance all the time, because that can become a little bit of a pain. So what I want to do then first of all is define and get scale x, and once this becomes apparent what's going on, you can really just download the code here, I would say, and just copy it in, because it's really not very pleasant probably to do. So we want to say cgame manager, and then we want our instance, and I have to make sure the spelling is correct here because obviously there's no checking, and then we want to say get scale x. So whenever we use now get scale x like so, it'll actually put this in the place, which obviously saves us a huge amount of typing because we'll be using it a lot. We want the get scale y, and we'll say get scale y. And then in the last but not least, we want get scale factor. So we'll call it FAC, and here we've got get scale factor. I'll just copy it from there like so. So that's getting our scale factors. And now we want to have a macro for when we actually want to scale a value. So if we want to scale something in the x, just say p, then we'll say p multiplied by, and it's get scale x. And then obviously if we want to scale in the y, then it's exactly the same as this but replaced with y. So this will scale a point that we give, or either as an x or a y, by the x or a y scale. If we want then to scale a position, so where we send in a position with an X and a Y, then we've got our X and our Y sent in here, like so. And what we'll do now is say we have our vec2, and now it gets a little bit complicated, so I'll spread things out, but we want our get scale X multiplied by our X and multiplied by our get scale factor. So this scales in a position that we're giving. This allows us to give, essentially, if we want something at 350 by 400, then this will, using this scale factor, scale that down to 175 by 200 or upwards doubled, and then also scale it in the correct X direction. Like I said, at first when you see this it's a bit confusing, but it's essentially just scaling everything according to HD, UHD and ND, and also then appropriately for the aspect ratio in each direction. So we've got that get scale factor, and then we want to do exactly the same thing then for the Y direction. Actually, it's a macro. I'll put this all on one line. So get scale Y with the Y and get scale factor, like so. Then we have scale font. So now I've seen this, I guess we must need to scale the fonts appropriately. Again, with the number that we want to scale here, and we'll scale this, the fonts get scaled in the Y direction, so we have our P multiplied by our scale Y multiplied by our get scale factor, I think. Just looking at my notes next to me so I don't get this wrong. Now what I want to do is have a macro for getting the file name, so get file name, sending in our array, the length, the name, and the extension here, like so. And just use a new line there with a macro with a backslash so we can see things a little get better. And we want C a manager, game manager instance, and then it's get file name with the A, L, N, and E, like so. So that's then can be used to get our file name without having to type this CGameManager instance and stuff. And now the last couple of things. One is define and scale node, and we'll say XY. So this scales something in the X direction for the X scale, and then in the Y direction for the Y scale. And you might think, well, we need to do this all the time. But actually, when it comes to scaling our tubes and our robin and things like that, we'll scale always based on the Y scale, because it's the Y, the gaps between the tubes and things, that make the gameplay difficult or not. Same with the speeds and things. It's all based on the amount of stretching or compressing we have to do versus 640 in the Y direction. So sometimes we need to do one or the other. So we'll take this n then for our node that we're scaling, and we just say n and set scale x with get scale x, and then another one, I want a semicolon here, and I'm just going to copy that and paste it in here, and set scale y with get scale y, and here we don't obviously need a semicolon. Okay, so that's scale node XY, and last but not least we'll have a scale node Y, so I'll just copy this for when we just need to scale in the Y, call it Y, and then it's get scale Y and no semicolon or anything. So very long-winded unfortunately, but that's now done and means that we completely have a setup of all of our scale factors and everything for the application. If I just go into hello world scene.cpp, then at the top here I want to include cGameManager.h, and what we need to do then with our instance, and I'm just going to drop into the header here and take this instance here, is we need to call this setup scale factors before we do anything else. So back into hello world scene here then, once we've got our origins and things, we'll just go cGameManager and set up scale factors so that everything's set up. And in fact, let's just log this to the screen just to check everything's okay. So what we want to say then is we've got the scale factor, I'll say 0.2f, And now I'll just make a space and just copy this so I can copy a couple of things in. We'll have the scale X and the scale Y in here. So the scale X and the scale Y. I'm sorry this is a little bit long-winded, but I think it's worth it just to see that everything is okay. So just enter here. Let's have the scale factor, scale X, and the scale Y, like so. So at least we've got that then logged properly to the screen when the application starts. So the first thing I'm going to do is just run the application very quickly. We haven't actually done anything with the scaling of the sprite yet, and just check that that's working. And you see that we've got scale of 1.00 as we should have in the X and Y direction. And now let's change the resolution slightly in the app delegate, and let's make this 800 by 600 and run. And now things won't be quite as good from the picture's point of view, but the important thing is the scaling. So what's happening is this is smaller than our images, so it looks like they're fitting, but you can already see the floors higher. So we've got scale factor of 1.00, which we should have because we're not small enough to be using the ND graphics, but now we've got our 0.83 and 0.94 in either of the directions. So what we'll be wanting to do is actually then scale our images. So to do that then, we can start using our macros. And this is the last little bit of this video, and that's then down in this section here. So the first thing I want to do is set up a character array here, and I'll call this file name because we'll be using that to get the file name. Let's give it 32 characters. We won't have anything else longer than that. And what we can do now then is we want to get the file name, so we can say get file name, and now we're sending in the array, which is our file name array. The length that we have is 32. The name that we have is BG, and the extension that we have is .png. And now this macro will call our game manager and use this information then to build our background-HD or whatever we need PNG. So now I can replace this here then with a file name like so, and now we've got the correct file name being called, or being called for the correct resource. Here then I'll just change this to floor, and again I want file name inside here. And now we can look at the scaling, and what we want to do for the background is actually scale node in X, Y, and we'll do this before we set the position or anything like that. So we'll say scale node X, Y, and the node that we're scaling here then is our BG sprite. And then for the floor we also want to scale in the XY to get it the right width and also the right height. The robin, for example, will only when it's added to be scaled in the Y direction because it's important for the gaps in the tubes that everything stays the same from device to device. So we have scale node XY and floor sprite. So assuming all of that then is working and running okay, now if I run the application we should see that the floor looks proportionally better with this 800 by 600. And indeed you can see it does. If you remember what that looks like, and I just take this scaling off here for the floor and run the application again, the floor appears to have a different thickness than what it actually does have. That's not maybe quite as visible as I'd want actually. Let's try a different aspect ratio. Let's make it actually not very high at all, so 800 by 500 and run the application. There's no scaling here. And now you can clearly see that in proportion to the screen the floor is too thick. And now if I apply the scaling to the floor, you can see that the floor is back at the correct proportion again. Okay then, and obviously the get file name is working, otherwise we'd have to crash without it being able to find the correct files. Okay, good then, so that was a pretty long video. I apologise about that. They're not normally meant to be this long, but it's really important to get this scaling stuff already in, and we're now in the position to be able to scale our images and things irrelevant of what the aspect ratio or number of pixels is, and also select and use the correct definition of graphics. So again, apologise for the long video, but I hope it makes some sense, and we'll start actually getting into making the game with the robin and stuff in the next video. Thanks very much for watching. Comments, questions, criticisms welcome, as always, on YouTube.